UIT, were there someone from here last time?
What did you ask, sir?
No, my question is, were you there in the last lecture?
Yes, sir. We attended that lecture.
Okay, what did we do? Can you just briefly describe for the sake of everyone? So that just we can recap what we did last time. What are the different topics?
Narrowband approximation.
Okay. Thank you. What else? Anything else that you remember?
Thank you, sir.
Let me just quickly see if the recap, are you able to hear me?
Good morning, sir. Good morning, sir.
Recap, are you able to hear me?
Yes, sir. Good morning, sir. Good morning, sir.
Yeah, good morning. Can you remind me what we did last time? What are the topics we discussed last time?
Gaussian random variables and Rayleigh.
Okay. Go ahead.
Gaussian random
Okay. Yes.
Rayleigh fading channel.
Rayleigh fading channel. Which said that the channel is Rayleigh fading. What else?
Joint distribution function of
Which one? Rayleigh fading channel and
joint distribution function.
can you repeat it, please? Which distribution function?
Distribution function.
Not able to hear you.
Power relationship.
I think we are
Power
talking about the problem that. Are you talking about the problem that we did last time?
Yes, sir.
Okay. Alright, so I'm getting a general. Let me just do a quick recap. Are you able to hear me? First of all, I'm not able to. Are you able to hear me?
Yes,
I
sir.
hope everyone is able to hear me. So let me just go do a quick recap of what we did. First, we talked about the Rayleigh fading channel. We said, let me just write it down what we said. We said YBT equals H times SBT, where this H is the fading channel coefficient. We said that this H is the fading channel coefficient, and also what we said was this H,
Yes,
this
sir.
fading coefficient H, I can represent it as H is equal to X plus J times Y. Is that not? Is that correct?
Sir.
And since X and Y are each sum of a large number of random components, therefore X is
XY
Gaussian.
Gaussian random.
Also Y is
Gaussian random.
Gaussian random variable. And we said each of them are mean,
Mean
0
and variance
and variance sigma square is equal to
half.
half. And further we said the following thing: if we look at if we look at now, if I write this thing in terms of the amplitude and phase, so if I write this as a e to the power of j phi, where a is equal to, now you can tell me a is equal to, what is a equal to? Square root of
x square plus y square.
x square plus y square, and phi is equal to
Tan inverse of y by x.
tan inverse of y by x. Then what I have is, what is the distribution of a? F of a
Of a
is equal to
2a
2a
power
e
minus
to the power of
minus a square.
a square. F of a is equal to 2a e to the power of minus
Minus
a square. Yeah, and this we said is, what is this distribution? This distribution is known as the,
Rayleigh distribution.
this is Rayleigh distribution. Thank you, Rayleigh distribution. Thank you very much. Rayleigh. This is the Rayleigh distribution. Okay. So let me just try to quickly go to some other college here, try to start an interaction. Thank you, VCAP, I got the answers. Thank you. Let me just go to TKM Kerala, try to see if I can establish an interaction. TKM, are you able to hear me? TKM college? Not sure if they're able to hear me. TKM college, are you able to hear me? RVCE, RVCE, I'm not able to establish an interaction. Oxford, poets, Oxford also was not able to establish an interaction. Let me just quickly go to MIT. MIT, are you able to hear me? MIT College, Karnataka, are you able to hear me? Hello?
Yes,
MIT
sir.
College, are you able to hear me?
Yes, sir.
Can you remind me what do you remember, what was the distribution of the phase of the wireless channel? Does anyone remember what was the distribution of the phase? The phase factor, what was the distribution of the phase? See, we have written h as a e to the a e raised to j phi. What is the distribution of a is Rayleigh distribution. What is the distribution of the phase factor phi? Does anyone remember?
2 pi.
What is that?
1 by 2 pi, sir.
1 over 2 pi, correct. Your volume is little low. Can you be a little louder, please? So the distribution of the phase factor, that is if I look at the phase, the distribution of the phase is 1 over 2 pi within minus pi less than or equal to phi less than or equal to pi. Therefore, the phase distribution, that is a uniform distribution basically. The phase distribution is uniform between minus pi and pi. This is a uniform phase distribution. Okay. All right. Thank you. And also we did a question last time. I'm just let me try to just recall. Just try to see if there is someone who can help me recall what we did in the question. That is, we looked at what is the probability. What is the probability that power is less than minus 20, power is less than minus 20 dB. I hope everyone remembers that we said what is the probability that the power is less than minus 20 dB. Let me try to see if someone remembers that calculation. Let me quickly go to GIT. GIT college, does anyone remember how we calculated what is the probability that the received power is less than minus 20 dB, received power is less than minus 20 dB? GIT college, does anyone remember? I'm not able to hear anything from, let me just quickly go to GCT college, are you able to hear me?
Hello?
Hello GCT college, are you able to hear me?
Yes, sir. Here.
Were you there in the last lecture? Were there any students there in the last lecture?
Hello.
Hello, do you remember this problem? What is the probability that the power is less than minus 20 dB?
We have to take 10 power minus 2 by solving that.
Okay, 10 power, hang on, 10 power minus 2. So I'm saying 10 log 10
20.
a square less than equal to minus 20, right? dB power is nothing but 10 log 10 a square. So that gives me, what is the inequality for a now? Can someone prompt me what is the inequality for a? Can someone respond on chat? 10 log 10 a square less than minus 20. What is the inequality for a? Can someone prompt me on chat what is the inequality for a?
Point 1. Is it point 1?
A is less than or equal to
A less than or equal to point 1.
A less than or equal to point 1. Therefore, what is the probability that A is less than or equal to point 1?
Integral point 1 to infinity.
Integral probability A less than or equal to point 1 is equal to integral
Point 1 to infinity.
not point 1 to infinity. A is less than or equal to point 1.
Minus infinity to point 1.
Minus infinity to point 1, but A is greater than or equal to 0, so I'm simply going to write it point 1 and I have to integrate the distribution, correct? That is 2A to the power of minus a square dA, right? And this is equal to, what is this integral, does anyone remember? Yeah, there is a lot of echo, I think, in this college, GCT, I think, so I just tried to go in this college, but I think I got the answer. Thank you very much. And let me just go to GEC. GEC, are you able to hear me? GEC College, Tamil Nadu, is this GEC College? GEC College, are you able to hear me? Not able to interact with them. Okay, let me just quickly go to, continue with the lecture. So that is basically 2a e power minus a square. If I integrate this, we said last time, this is equal to e power minus a square between the limit 0 and 0.1. Therefore, this is equal to 1 minus e power minus 0.01, which is equal to, I think the answer, if people remember, that was 9.95 into 10 to the power of minus 3. So this is the probability. This is basically the probability that the received power is less than minus 20 dB. So what we are asking is, we are asking if the fading channel, if we have a Rayleigh fading channel, yeah, GIT, I think there is some problems. Can you resolve with the technical support? So if you have a Rayleigh fading channel And basically what we are saying is what is the probability that in this Rayleigh fading channel that the received power is less than minus 20 dB, right? And this is basically 9.95 into 10 raised to minus 3. That is probability that the received power is less than 10 to the power less than minus 20 dB. Okay. Alright, so now let us go on with other aspects. Now what I want to do is I want to start talking about also what is the bit error rate. But before I start about talking about the bit error rate, there is something also minor I want to carry out, and that is the following thing, which is the distribution. I want to perform a transformation of random variables. I want to look at what is the distribution of the channel gain. That is, we have looked at the distribution of the amplitude. We have looked at the distribution of the amplitude equals square root of x square plus y square. I want to look at what is the distribution of the channel gain. G equals a square equals x square plus y square. Fine. I want to look at what is the distribution of G equals a square plus y square. Let me just go to PSG College of Technology. PSG College, are you there? Have you studied transformation of random variables? I think there is some echo that is coming. PSG College, how do I transform f of a equals 2a e power minus a square. What is f of g? That is what is the distribution of this gain? Can someone tell me? So instead of a, I will substitute g. So a is equal to square root of g. So I will have 2 square root of g e to the power of minus. So e to the power of minus g. Derivative of the function is 2a and a is nothing but square root of g. This is equal to e to the power of minus g. I'll just go away from this because there is some SGG, I think there is some problem. So let me just go to LNMIT College. Can you hear me? LNMIT, are you able to hear me?
Yes, sir.
Are you able to follow what I just did? So we are saying basically that if the channel amplitude is Rayleigh distributed, then the square of that is G is equal to x square plus y square, which is the power gain. You can also think of it as the power gain that is exponentially distributed. Are you able to follow this? This part you are able to follow?
Yes, sir.
Is that fine? Okay. And so this gain G, which is exponentially distributed, that is f of g is equal to e to the power of minus g, which is an exponential function. So this is an exponential distribution, right? This is the distribution of the gain. In fact, the Rayleigh distribution, which is the distribution of a, that looks as follows. That is, if I look at the Rayleigh distribution, that is 2a e power minus a square, that looks as follows. It exists for a greater than or equal to 0. What I am plotting here is the distribution of a, that is 2a e to the power of minus A square, and this is the Rayleigh distribution. This is the Rayleigh This is the Rayleigh distribution. Alright, okay, is there any question so far? UIT college, I'm getting a question. Let me just quickly go to UIT college. Let me try to understand. Let me just try to address their concern. UIT college, where is UIT? UIT, you have a question?
Hello.
Hello, go ahead please.
Sir, I didn't understand how you derived the expression for fg as a function of g.
Yeah, okay, let us go step by step. See, I have fa is equal to 2a e to the power of minus a square. Let me just quickly repeat this part again. That part you have followed?
Yes, sir.
Now from here, see, g is equal to a square. Is that okay?
Yes, sir.
So if g is equal to a square, now how should I modify this 2a e to the power of minus? What happens to, so I have to substitute for a, I have to substitute g, right?
Yes.
So that will be, what will that be? 2
root g.
2 root g, correct?
E raised to power minus g.
E raised to power minus g. And now for transformation of random variables, I also have to divide by the derivative of the function. So I have to derive by eg by dA. What is dg by dA?
That's 2 root g.
Okay, that is exactly 2 root g, correct. E minus g let me just write it over here. So that is 2 square root of g e raised to minus g divided by, again dg by dA is 2a, but a is square root of g. So that is 2 square root of g. Is that clear now? And therefore these things cancel, and what we are left with is e to the power of minus g. Thank you. Right, so that is exponential distribution. Okay, so that is the distribution of the power. So this completes the characterization of the wireless channel. We said something interesting. We said a couple of things. We said basically the channel is a fading channel because of the multipath, because of the nature of the multipath propagation and the multipath interference. And this fading channel, the amplitude has a Rayleigh distribution, that is a Rayleigh fading channel, and the gain, which is a square, has an exponential distribution. Now we are going to go into the next important aspect of the course, which is bit error rate. I want to start with the bit error rate analysis of wireless communication. What is the bit error rate? Bit error rate is an important measure to characterize, or it's an important criteria to characterize or measure the performance of a wireless communications. Bit error rate, this is also denoted by E, E, R. All of you must be familiar with this. This is an important criteria. This is an important criterion to characterize performance of any communication So bit error rate is basically, it is an important criteria to characterize the performance of any communication system. I'm trying to get let me just try to go to a different college here, try to see if I can if I can if I can quickly interact with some of them. Let me just go to PECUT. I did not get a chance to interact with them. PECUT, are you able to hear me? PECUT, are you able to hear me? Punjab Engineering College of University, I think University College of Technology.
Yes, sir. We are able to listen to you.
You are able to hear me? You are able to see what I am saying about bit error rate? Are you familiar with bit error rate?
Yes, sir. It is an important criteria, as you mentioned, to characterize.
Performance of a communication system. All right, thank you. Let me just try to see if I can establish interaction with MU College Jaipur. Is it MUJPR? Which college is this again?
University Jaipur.
Which one? Can you repeat it, please?
It's Manipal University Jaipur.
Okay, Manipal University, JPR. Are you able to follow what I'm saying about the bit error rate? Are you familiar with the bit error rate?
Yes, sir. Yes,
Can
sir.
you briefly describe to me what is the concept of bit error rate? Can you just explain to me intuitively what is the concept of bit error rate? What is the concept?
The concept is like how many bits we can transfer like without any error from the transmitter to the receiver.
Well, how many bits we can transfer? Well, that is slightly tricky.
Correctly.
Not how many bits we can. What is the definition of bit error rate? Can you define in simple terms? Simpler terms. Can someone prompt me on chat what is the simple definition of bit error rate? What is the definition of bit error rate? Can someone prompt me on a chat in simple terms what is the definition of bit error rate?
So correctly, I don't know the exact definition of bit rate.
Yeah, that's what I'm just trying to see if there is anyone on this forum who can prompt me. Any college, can you prompt me with the definition of bit error rate? Can someone prompt me? On chat, can someone respond? It is not the number of bits received with error, because bit error rate is less than 1. Change in bit number of erroneous bits, it is not the number. Okay, GEC College Tamil Nadu, I am getting an answer. Ratio of number of errors to number of bits transmitted. Yeah, let me just interact with GEC College. That is the correct. That is the correct answer. The bit error rate is not the number of bits in error or correct. The bit error rate is basically, it is the ratio of the number of bits in error. GEC College, did you respond?
Yes, sir.
So what is the bit error rate? Can you describe it again, please?
Ratio of number of errors to number of bits transmitted.
Yeah. So bit error rate is, yeah, it's also can be said of the percentage of bits received in error. That is, if I transmit, let's say 10,000 bits. If I transmit 10,000 bits and 10 bits are in error, what is the bit error rate? The bit error rate is equal to, what is the bit error rate if 10 bits are in error out of 10,000? Can someone tell me the answer?
10 by 10.
10 by 10,000. So bit error rate will be 10 divided by, and what is that? That is 0.0
0 0 0
0.001, right? Fine. So bit error rate is nothing but the number of bits received in error to the total number of bits That is 10 to the power of minus 3 PSGCT. I'm also getting the answer, and that is basically, that is also basically it is the probability of a bit being in error. The bit error rate is also nothing but the bit error rate is also basically the probability of the bit in error. The bit error rate is also the probability of bit error. Now, to basically introduce you to this concept of bit error rate, to just refresh some concepts, I'm going to first compute what is the bit error rate for a conventional digital communication system, that is an AWGN communication system. Then what we are going to do is we are going to look at the bit error rate of a fading communication system. Is that okay? So first what I'm going to do is I'm going to start with bit error rate of AWGN communication system, where AWGN stands for additive wide. Can someone prompt me what AWGN means? Additive. Has someone heard about AWGN? What does AWGN stand for? Let me just go to CIT CMB. GIT. Let me just quickly go to GIT. GIT, are you able to hear me? What does AWGN
Additive white Gaussian noise. So additive white Gaussian noise.
Additive white. Thank you very much. Additive white Gaussian. AWGN stands for additive white Gaussian noise. Thank you. VCAP. I also got the answer from VCAP. I think people are responding. Thank you very much. TKM seems like they have some question. Let me just quickly. TKM, did you have any question? I saw a hand raised. This thing from you.
No sir, no sir.
Okay. I think you are prompt answer. There is still an echo from you. So let me just quickly go back to GCT. Now GCT, see, I think we are GIT. That is was the college that I had come from. That I was just interacting with GIT. So I can represent an AWGN system model simply as y is equal to x plus n, right? Where x is the transmitted. X is the, what is x? X is the transmitted X is the transmitted symbol and N is, what is N is the noise. And we can clearly see that the noise is additive. Everyone can see that the noise is additive. What does Gaussian mean? Can GIT, can you prompt me what is the meaning of Gaussian?
So the noise is represented in terms of Gaussian distribution.
Okay, thank you. So the noise is a Gaussian distributed noise. So the noise follows Gaussian distribution. We already saw the Gaussian distribution is 1 pi 2 pi sigma square root of 2 pi sigma square e raised to minus n square by 2 sigma square. RVIT college, I got your question. That is additive white Gaussian noise. I am explaining that. That is what I am explaining. What is additive white Gaussian noise? I am saying the noise is additive and it is Gaussian. Can someone GIT, can you finally also tell me what is the meaning of white noise? Why is it white noise? Can you explain to me what is the meaning of the last? What does it mean to say that the noise is white?
Sorry sir, we don't remember.
Okay, not a problem. Let me just go to, okay, GEC College Tamil Nadu. I think they are prompting me the answer. GEC College, let me just go to GEC College. Okay, let me also go to, I think GEC I have already interacted with once. Let me just go to PSG College. They are also prompting the answer. PSG college. PSG, what does it mean to say the noise is white? It has? Yeah, power spectral. We'll come to that. But even before, what is the more?
It contains all the frequencies.
It contains all the frequencies. Can you tell me what is the time What is that?
It's autocorrelation function.
It is the
autocorrelation function is impulse.
Autocorrelation function is impulse. Correct. So in this case, if I write the expected value of times NL, which is the correlation of the noise value. What can you say about this? Yeah. Let me just quickly go to some other. Let me just continue with BIT. I think. SGG, SIET, are you able to see me? SGG, SIET, are you able to see and hear me? Okay, fine. I think there are some technical issues. Let me continue. So the autocorrelation is impulse, which means if I take two noise samples at different time instant, that is if k is not equal to n, then the expected value is 0. Let me just write it clearly in the next page. So let me just quickly write it. This is expected value of nk into n. That is expected value. That is, if I look at the time correlation between the noise samples, nk into nl, this is equal to 0 if k not equals L, and this is equal to sigma square if k equals L. So what this says is, if we look at the autocorrelation function, the autocorrelation function is an impulse of strength sigma square at 0. Therefore, if I look at the power spectral density, which is nothing but the frequency response of the autocorrelation, that is basically, it is sigma square from minus, that is the impulse response of the frequency response of an impulse is basically it is flat from minus infinity to infinity. Therefore, the power spectral density is a flat power spectral density which contains all frequencies. This is also known as a white spectrum. This is the meaning of white spectrum. So the power spectral density which contains all frequencies and in equal power, that is the power spectral density is flat, which means the autocorrelation is an impulse. This is known as white noise. Therefore, we have additive white Gaussian noise. Additive white Gaussian noise. Noise is additive, it is Gaussian distributed, and the power spectral density is flat, which means basically the autocorrelation is an impulse function. SGG, SIET, hopefully everyone who was seeing this is able to understand this. So now let me go back to my AWGN channel model. Remember, my AWGN channel model is y equals x plus n. So let me quickly go back to my system model. Y is equal to now we have to calculate the bit error rate. Now let us say I am transmitting BPSK symbols. See, I am transmitting BPSK symbols plus or minus 1. Now I want to modulate, I want to also transmit them at a power P. So plus 1 I am going to transmit as plus square root of P. Minus 1 I am going to transmit as minus square root of P. Is that clear? Is that clear to everyone what I am doing? So if I have a transmit a symbol plus 1, I am going to transmit as plus square root of P. If I have minus 1, I am going to transmit as minus square root of P. Therefore average power, what is the average power? Average power, can someone tell me what is the average power of this scheme? Average power is equal to, if plus 1 and minus 1 occur with equal probability, that is half power for 1 is square root of P square, that is P, plus power for minus 1 is minus square root of P of P, that is P. Therefore total power, that is power that is being transmitted, is P. That is basically if I am transmitting plus square root of P and minus square root of P for plus 1 and minus 1 respectively. This is also known as, this modulation, this is also known as BPSK modulation. Can someone prompt me through chat what is BPSK modulation? What is BPSK modulation? Can someone prompt me? Can someone answer this? What is BPSK modulation? Can someone answer this via chat? Binary PSK, GEC College Tamil Nadu, that is correct. What does it? Can you also expand PSK? PSG College, College Coimbatore, thank you. That is binary phase shift, MIT, I am also getting the answer. That is BPSK stands for binary phase shift key. Binary phase shift keying. Why is it binary phase shift? Thank you. I'm also getting the answer because look at this. We are using two phases. One is plus 1 or minus 1 that corresponds to phase of 0 or pi. We are using two phases. Therefore, this is binary phase shift keying modulation. Now let us go on to the next aspect. See, we said the noise is a Gaussian noise. Noise is zero mean Gaussian noise. Therefore, can someone tell me what is the distribution? That is Gaussian distribution. This is a bell-shaped curve which is centered at 0. Right? So this is the distribution of the noise. So this is the noise now also we said we have y is equal to x plus n y is equal to x plus n, x is equal to plus or minus square root of p. Now can someone tell me if I transmit plus 1, that is plus square root of p, my received signal is plus square root of p plus n, that is it, plus square root of p is transmitted Now if plus square root of p is transmitted, can you tell me what is the resulting distribution? Can someone tell me that is corresponding to the transmission of plus square root of p, what is the resulting distribution? Is the question clear to everyone? What I am saying is, see, in a communication channel we are transmitting binary phase shift keying symbols, that is, which are plus or minus square root of p, and therefore the noise is Gaussian. First is the noise is Gaussian distributed of mean 0, variance sigma square. Corresponding to the transmission of plus square root of p, that is, if I have y is equal to plus square root of p plus n, what is the distribution of the received signal y? That is what I am asking is, what is the distribution of n plus square root of p? Can someone tell me what is the distribution of n plus square root of SVEC college? Let me just try to see if I can quickly interact. SVEC college. SMIT, I am not able to unfortunately interact with them. CSPIT is there. I am not able to interact with them. DCRU college, are you able to follow this? Which college is this? Sorry, I think I interacted with you last time, but I am not able to recollect it. DCRU, are you able to hear me?
Sir.
Are you able to follow what I am saying?
Yes, sir.
Are you able to follow what I am saying? Additive white Gaussian noise, were you able to follow it?
Yes, sir. Sir.
Now what I am saying is, my question, are you able to get what my question is? If the noise is Gaussian, mean 0, right? So n is Gaussian, mean 0, and I am transmitting plus square root of p. What is the distribution y? What is the distribution of the received signal y? Can someone tell me the answer to that?
It will shift upward.
It will shift upward, correct? What is the distribution going to be? Can you say it will shift upward? What is the distribution going to be?
It will shift upward by root p. This
By
distribution will
square
shift
root of
upward.
square root of p. Thank you. That is the correct answer. I got the answer. I think PSG college is also replying. I think the answer everyone is familiar is n plus square root of p. If n is 0, mean the only thing that will happen is basically it is Gaussian, but now it will be centered at plus square root of p. Therefore, I will have corresponding to transmission of, I will have Gaussian noise, but Gaussian noise shifted by square root of p. What this says, if square root of p is transmitted, what is the received amplitude? The received signal is a Gaussian signal with mean square root of p. Similarly, if minus square root of p is transmitted, now everyone can see this is a received signal which is a Gaussian with mean minus square root of p. Therefore, corresponding to transmission of plus square root of p or minus square root of p, I basically have, if plus square root of p is transmitted, I have Gaussian, which is mean plus square root of p. If minus square root of p is transmitted, I have Gaussian with square minus square root of minus p. Now therefore, here you can see both the Gaussians intersect at 0. That is, if you can see at this point, both the probabilities are equal. That is, equal probabilities or equal probability Therefore, you can see if y is greater than 0, then there is greater probability of square root of p. If y is less than 0, then there is greater probability of minus square root of p. So my detection scheme is at the receiver, the detection scheme I can employ is, can someone tell me what is the detection scheme? Thank you. Let me just quickly go to some other college, GHRC. I did not get a chance to interact with them. Let me try to interact with them. GHRC, are you able to hear me? MIT, I think they have raised their hand. MIT college, are you able to see me? Are you able to hear me? MIT college, are you able to hear me?
Yes, sir.
Was there a question from you? Okay, several colleges I'm not able to interact with them because I think there is no video. GIT college, let me just go to GIT college. Are you able to follow what I'm saying so far?
Yes, sir.
So what I'm saying is, if it is plus square root of p is transmitted, then it is a Gaussian with mean plus square root of p. If minus square root of p is transmitted, it is a Gaussian with minus square root of p. Therefore, what is the detector I can use here?
So I think we can use the earlier which you explained of binary phase shift keying itself.
Yeah, binary phase shift keying.
Yes,
But what is the detection scheme? When can I say that plus square root? See, at the receiver, if y is equal to, how can I map y to plus square root of p or minus square root of p? That is my question. The question is, depending on what I see, signal y at the receiver, how can I say if plus square root of p has been transmitted or minus square root of p has been transmitted? Is the question clear?
So we can use a comparator where root p can act as a threshold. Zero.
Root p,
No,
what
no,
is the threshold? Can you think a little bit about what is the threshold?
So threshold is 0, so that if the transmitted signal is above this, it is taken as root p, the probability of transmission. If it is lesser, then it can be as minus root p.
Okay, fine. So if you can see clearly, if y is equal to, if receive signal y by symmetry and also by using the threshold, if y is greater than 0, then I can conclude square root of p. If y is less than 0, then I can conclude minus square root of p, right? Now, will this always be error free or will there be errors? GIT college, can you tell me, with this detection scheme, will this be error free or will there be errors?
So there can be errors.
When will the error occur? Can you tell me when will the error occur?
Just below the point, just when the transition takes place.
Can you be a bit more specific? What do you mean when? What is the criteria corresponding to error? Can you elaborate a little bit? What is the criteria corresponding to error? Can someone elaborate a little bit more?
So even if we have transmitted a bit 1 with root p as the amplitude, and still in case if we are getting some value which is below 0, then there can be a error.
I hope everyone is able to follow. The correct answer is the following thing, that is, if we have transmitted square root of p and received value of y is less than 0, that is, we are speaking about this probability, that is, if we have transmitted y plus square root of p and the received amplitude is less than 0, or if we have transmitted minus p and the received amplitude is greater than 0, then there is going to be an error. So error will occur, let me just go to the next page and error will occur in two scenarios. Sorry, somehow I am not able to go to the next page. This has frozen. I hope everyone is able to hear me. plus square root p error will occur if plus square root p is transmitted. So error will occur plus square root of p is transmitted and y is less than 0, or on the other hand also if minus square root of p is transmitted and y is greater than 0. I hope everyone is able to follow this part. Let me just try to quickly interact with a couple of colleges and see. MIT, I'm not able to. MIT, are you able to follow this? What I've just said so far? When is the error going to occur?
No.
Is that clear? GHRC, are you able to follow? I'm not able to see your video. Let me just quickly go to a college. DCRU, CSPIT, all these several colleges I'm not able. BTKIT, I just saw them. BTKIT, I'm not able to see your video. BEC college also I'm not able to see your video. Let me just quickly go to RVC, also I cannot see your video. UIT, let me just go to UIT and I'll finish with that. UIT college, are you able to follow what I just said? When is there going to be bit error?
Yes, sir.
You're able to follow it, right? What I'm saying is when you're transmitting plus square root of p, but the noise is negative so that y is less than 0, or when you're transmitting minus square root of p and noise has a very positive, high positive value so that received y is greater than 0, then you're going to have bit error, right? So the next lecture we are going to calculate the probability of bit error. Alright, so this is basically we've talked about the bit error rate of an AWGN channel. Next lecture we'll calculate the probability of bit error. UIT, okay, thank you very much. I hope everyone has been able to follow it. So we'll talk again more about this bit error rate in the next lecture. Thank you. So I'll stop right now. We'll meet again in the next lecture. Thank you very much. Thank you everyone.